Now in section 4.2, there's two main objectives we're going to do. Number 6 says approximate the values of sine, cosine, or tangent given a unit circle or calculator. So it's really going to be the introduction to how you actually use the unit circle. And then number 7, we're going to state an interval where sine, cosine, and or tangent are positive and or negative. Now after doing the activity for section 4.2, what you should have come up with is this unit circle right here. And this is what we call the approximate unit circle. So this is not the exact unit circle. That's going to be covered in a different section, and is really our ultimate goal is to get to the exact number. But it's approximate right now because, for example, 0.866 is a rounded decimal. 0.707 is a rounded decimal. But what you want to glean from this is whenever we start on a unit circle, we always start what I like to call the home base. And the home base is always here on the positive x-axis. And in a unit circle in trigonometry, we move counterclockwise is the correct direction, so we move this way. Now, if we were asked to sketch and find where we land at 30 degrees, if we were to take a protractor and lie it down and find out where 30 degrees is, it would be right here. Now, to land at this particular 30 degrees on the outside of this unit circle, and it's a unit circle because the radius is equal to 1 on this entire circle, but if we were to do that, because the radius is 1, that means the outside of the circle here is 1, this inside is 0. Every dash on here is a 0.1. It's a tenth of a mark. So to land at 30 degrees, what you have to do is you have to go right 0.866 and you go up 1/2. That gives us this ordered pair to land on the unit circle at 30 degrees. On a unit circle, the ordered pair of x, y that we see right here is always associated now with cosine and sine. So this x, y is the same as saying the cosine of an angle and the sine of an angle. Well, what angle did we move? Well, this ordered pair represents exactly the cosine of 30 degrees and the sine of 30 degrees. So if you go into your calculator, you have to make sure you're in the degree mode. So look at the mode button on your calculator. Double check it says degree. You do not want it in radian mode. And then all you would do is go and hit the cosine of 30 on the calculator, and you're going to get 0.866. Then hit the sine of 30, and you should get the fraction will be 0.5. Now, what tangent is, by definition, tangent is the slope of the ray that creates the angle. So, for example, this is the 30-degree angle. This here is the ray that gets created by a 30-degree angle. And to find the slope of that line, you would do just like you would in algebra. By definition, slope is rise over run. Well, in this case, the rise movement is not our y movement, but it's sine. So to find tangent of an angle, what you do is do the slope, again, which is rise over run, or y over x. In this case, our y now, in the unit circle world, is the word sine, and the x is the cosine. So you can find the tangent, or really how steep is that red line created on this graph, by doing the sine of the angle over the cosine of the angle. What was the angle that we moved? We moved 30 degrees. So we do the sine of 30 degrees and divide it by the cosine of 30 degrees. And when you do that, you will get the tangent of 30 degrees. Now, the reason I had that conversation with you is to look at this table. One of the things you're going to be asked, for example, is if you move degrees versus radians. Degrees and radians, we know we can get to either one. Let's just do a quick review of this. On a unit circle, again, we always start here at home base. Anywhere between 0 and 90 degrees is right here. That's 0 to 90 degrees. Well, 0 to 90 degrees is the same as saying 0 pi's up to pi over 2. Remember, pi over 2 is just half of a pi. On a unit circle, that's 1 pi. If you just move half of that, you move half of a pi. What quadrant is that? That's in quadrant 1. The value of cosine, any ordered pair that sits on this arc, no matter where it is, since cosine is the x movement, I'm always going to have to move to the right. So the value of cosine has to be positive. To graph any of these ordered pairs, I then have to also move up. That up movement is, the sign is positive. What's the slope of the line created by that angle movement? Well, if I move this angle, or this angle, or this angle, or this angle, they're all upward sloping lines. So their tangents have to have a positive slope. Or remember, by definition, tangent is sine over cosine. Well, if the sine here is positive, and the cosine is positive, a positive number divided by a positive number has to also be a positive number, which gives us a positive tangent. Okay, let's complete this. If we look at from 90 to 180 degrees, we're talking the second quadrant. That's the same as pi over 2 to pi radians. That's in quadrant 2. To get anything over there, what you'd have to do is move left and up. That left movement is a negative x movement or negative cosine. That up movement is the y movement or positive sine. The tangent, the angle of anything in here, it's a downward sloping graph. Sure, sine over cosine would say plus divided by a minus, which has to be a negative sign. Okay. The next one, we're going 180 to 270 degrees is right here. That's the same as pi to 3/2 pi. That's quadrant 3. And the cosine here, you have to go left, and then you have to go down. So cosine is left, so it's negative. Sine is down, so it's negative. Tangent has to be positive. If you were to draw what the rays look like, they're upward sloping if you read it left to right, or just do the negative divided by the negative. And the last one we have is going to be in quadrant 4. Quadrant 4 is 270 to 360. On here, cosine, I move right. Sine is down, so cosine is positive, sine is negative. Tangent would be sine over cosine, which is a negative, divided by a positive number. It's going to have to be a negative sign. And you can tell if you draw the rays, the angles are going downhill. So what we basically did in this 4.2 activity and starting into the official notes is this, is we've defined the unit circle. It's a circle with a center at the origin, which is right there, and the radius is 1. Where the x-axis is now cosine of theta, or the angle. The y-axis is the sine of theta, or the angle, such that our old ordered pair of xy has now become the new ordered pair, cosine of an angle and sine of an angle. Again, make sure you're in either, this angle movement, you can either be in degree mode or radian mode. You have to be very cautious on your calculator which mode you're in when you do that. Now let me show you how you would do this without a calculator and with a calculator. The cosine of pi. Let me show you on without a calculator. If you look at the unit circle here, you want to move pi units. So I always start here, again, home base. Pi units, a full circle is 2 pi, so half a circle is 1 pi, which lands me right there. That is a pi unit movement. Okay. And what they want to know is what's the cosine. It's as simple as this. Look at the ordered pair. Just remember, to graph this ordered pair, if the origin's here, I have to go to the left negative or 1, which is negative 1, and I go up 0. So that has to be the ordered pair, negative 1, 0. This right here is the cosine. This right here is the sine of that particular angle, or radian. So the cosine of pi has to be equal to negative 1. The sine of pi, we've already moved the pi radian movement. Sine is the y value. The answer is 0. Now double check this on your calculator. They are not using degrees here. They're using radians. So double check that your mode is in radian mode. And just type in cosine of pi. If you don't get negative 1, you have a typo somewhere. Now we did talk about tangent already, but let's just figure out how to fill in the blank. Tangent is the blank of the ray. If you had to choose between these 5 words, tangent is what we call the slope of the ray. Now, the ray is the angle movement. So there's the ray of this angle movement. Let's say it's about 50 degrees. Now recall, if I want to know where that lands on the circle, all I have to do is find that ordered pair. Very easy to find. I do the cosine of 50 degrees. That's my x, and then the sine of 50 degrees is the y. Put that in my calculator in degree mode. Okay. Now, tangent is the slope. Well, slope is just rise over run. Well, to land at this ordered pair, I had to rise that. That's the y. I had to run that, that's the x. Well, in tangent world, if tangent slope, that's y over x. Remember, y is just the sine. The y movement is sine over cosine, so this is the definition of tangent. Now, I'm jumping a slide and going to this one next. So let's just take a look at this one first. It says here the 0.100 is rotated 13/15 of a pi. 13/15 is not exactly 1, so it's a little under 1. Remember, a full circle is 1 pi movement. That would be 15/15. I want 13/15. So they already sketched it and they said, you know what, this is about 13/15 of a pi. They're just approximating. They want you to find the coordinates of the image to 3 decimal places. Now, this is not meant to be a hard question. To find the coordinates of this image, all you need to do is do the cosine and sine. They're in radian mode right now. So what you need to do is change your calculator, go to the mode, change it to radian. And when you do that, you're going to put 13 pi over 15 into cosine, and then do sine of 13 pi divided by 15. Now you need to be careful. We're in quadrant 2. Anything in quadrant 2 is always a left and up movement. Left is negative, up is positive. Without even the calculator, I know that this has to be the correct answer. So just be very cautious. Part B was put there because that is when, if you do it in the calculator in degree mode, that's what you're going to get, and it's wrong. Now to finish your notes on section 4.2, there's 4 examples left. This video is over. You need to now click into the second part of the 4.2 video to look into the other 4 problems.